We just wanted to had two caveats here. So SPSS is only one software that you can actually use to store and analyze data. There are lots of other softwares. So SAS, R, Excel can do a lot of things. And so this is just one of them. And all of them kind of do the same thing. So know that. And then the other thing is that there's a skill builder we did in 2017 that Melissa found that I actually did.
She forgot to do it. I'm like, did you already do this?
So there is, I think it's like the basics. So we have a little bit of review a little bit today, but because this is a two-parter, it allows us to do a little bit more with the material. But no, there is something on there that's excellent. Okay, learning objectives. So we have several. Hopefully by the end of today, you'll be able to name the two views in SPSS and describe their function, identify 3 ways to get data into SPSS, identify the parts of a database structure, understand how to check the integrity of your database structure, and understand some simple ways to check the quality of your data. And then the blue there, the last one, we'll do in part 2, where we're actually going to work with printed output. Wow. It's like a hands-on experience. So this is kind of going through, it's a little didactic, and then part 2 will be actually working with things. Okay, so objective 1, 2 views. So in SPSS, there are 2 views. One is called the variable view, and this is typically built first. And so when you open up SPSS, there's those 2 tabs at the bottom there. So one is variable view. So the first one is actually the second tab. But it sets up, I don't know what that is.
It's a WebEx thing.
Yeah. Ignore the WebEx.
I think it can be moved up to a corner, maybe.
So this view sets up your database structure. So before you even enter data or think about entering data, you have to set up the structure of your database first. And so this kind of tells you how the data should behave, which will hopefully make more sense. And then I'm stuck. Okay. And then the second view is called the data view, and this houses the actual data that you might enter or import from somewhere else. And so how the data behaves in this view is directed by what you put in variable view, so the structure. Okay, and we'll get into what that all means. But these 2 views are really important because you just don't want to open up SPSS and start entering numbers or text. You have to set up your structure first to tell you how that data should behave. Okay, several ways to get data into SPSS. One, the most boring way, is direct entry. And so, this gives you a screenshot of some data entry. So again, this is data view. This would assume you've already set up your data structure and you literally type things in, and that can be your data entry and your data storage.
Same way that you do in Excel. It's just a blank spreadsheet and you're just putting the numbers in down the rows.
Yeah, it's very exciting. Okay, so the second way is you can import data from REDCap into SPSS. So this is a little screenshot. There's 3 files that you would end up downloading to your computer, and then assuming you have SPSS, then it puts the data from REDCap into SPSS. Now this assumes that you've set up REDCap, the structure of that, well, or with some integrity. So if you set up your data structure wrong in REDCap, it's going to export that data wrong and then put it into SPSS wrong. So again, you have to set up the data structure first, which again we'll get into. And then the third way is import from CSV file.
So REDCap has that nice feature where it will do it in an SPSS file format and take all that information that you've already set up and transport it over. If you're unlucky and not working with REDCap, most applications will let you export your data as a .csv file. Like that's kind of the most basic file type you can have. It's almost like a text file essentially. Or sometimes you're getting data from another source, and the only way that they can give it to you is in a CSV file. So thankfully SPSS does have a function where it will import that data. So when you go to open the CSV file, it starts this little like text import wizard. And it asks you some basic questions. So it just wants to know like if there's a specific character like a comma or a space or whatever like between each of your variables, and if there's variable names at the top. And then it asks you for each of your variable names like what type of data it is, like if it's numeric or string or date. And one of the reasons why I want to show this to you is to show how little it actually asks. So there's a lot of information that is in that variable view that it's not asking you about. So unlike with REDCap, where it takes all the information, like your variable labels and all that other information, and it brings it all over for you, when you use a CSV file, it just takes the bare minimum and everything else just gets left blank. So there's a lot of work on the other end if you're importing from just a CSV file. So if you can get more detailed files from whatever you're working with, it's in your best interest. But worst case scenario, it can always import those basic CSV files. So the database structure. So we've kind of mentioned this a number of times now. So this is that variable view. So it's quite small up there. But across the top, you can see that there's the name of your variable, type, width, decimals, label values, missing, columns, align, measure, and role. So the variable name, so that's the name you give the variable. There can't be any spaces in it. Usually you want to be somewhat strategic here. So I've had a case where a student inputted data and they used, instead of the variable names, they used Q1 for question 1 and Q2 for question 2. Well, later when I'm looking at that, I have no idea what Q3 is or Q5 unless I have the entire survey memorized. So I just had to go back and like look at the original survey to figure out what each of my variables were. And also if questions get added to your survey tool, then now what happens when you have two Q10s? So you want to be pretty strategic with your variable name. And also, if you're working on very large surveys, so for example, I was on one where there was an entire section on like drug and alcohol use, an entire section on physical activity behaviors, eating behaviors. So like all of our physical activity questions, all of them started with the variable name with like PA for physical activity, and then something else identifying after. So just little tricks like that can make it a lot easier later when you're trying to work with this data by setting it up with some forethought at the beginning. So you set your variable name, the variable type, so again, if it's numeric, string, or date. Width, decimals, columns, and align, these are really just formatting things. The width is like how many characters you allow for that variable. Especially if you are doing direct entry, you might want to actually set the width because then that helps to avoid data entry errors. So example, if they're supposed to be entering something that's only one character and should only ever be one character, you might actually want to set that to 1 because then if somebody tries to enter something accidentally that's like 2 characters, it won't allow it. And then decimals, columns. Larkin and I both we've never used this before, but apparently in the data view, that's how wide the column is. I think most people just drag and drop their columns, so you'll probably never use that. And then align is the same thing as in Word, like just left, right. Your label is basically a description of the variable. And then values is where you set for each of the values that they input, like what the label will be. So,
yes, no.
Pardon?
Say yes, no.
Oh yeah, so like you could have like 0 for no and 1 for yes, or and those values will show up in output. So if somebody else is getting your output and they just see a whole bunch of like numbers, they can't really interpret that easily. But if you take the time to fill in those values, it means that on your output it'll be a lot easier for you to know what it is that you're looking at. And then missing, you can set missing. Some people just leave missing as blank. I've worked on some larger studies where like for missing, we'd use like 9.9, or we would have different types of missing, and so the researcher really wanted that to be included. So like 9.6 was if it was like a valid skip on the survey, so it was valid for them to skip a section. 9.9 was they just didn't fill it in. And so in this variable view, you can set that if the value of that variable is 9.9, that means it's missing. So it knows that that's not an actual answer. So then when you go to do your analysis, it doesn't think that someone answered 9.9 on that question. They know that it was a missing. And then for the measure, if it's scale, nominal, ordinal, and then roll, again, we have never used this, and apparently you can, it was said like, I don't know, I had a whole bunch of things we've never recognized and we've never used. So I'm putting that under the advanced column, and maybe in the future we'll get to what that's about. So database restructuring. So once you have your base data, like your raw data as it's been collected, there's some things that you might want to do in the restructuring. So first, correcting any errors. So sometimes when you import data, when you look through it, something that you actually had inputted as numeric for some reason, Excel thought that that column was a string, little things like that, that can, if you don't fix it here, later when you're doing your analysis, it can cause errors. Entering any missing information. So as I said, like when you import from a .csv file, none of those labels for your variables or your values will be there. So entering all that information. And then recoding variables. So under the transform menu, there's a few different options of things that you can do. So recoding variables, you can compute new variables based on existing ones. And so that's kind of a useful step to take. So for example, oftentimes if I'm using like chart data or something, it might have male and female as string, and that's how it gets imported. But if I go and run analyses, it doesn't know how to analyze that. So I have to recode it as like zeros and ones, for example. Or for BMI, if we only collected height and weight, this would be the stage where I would create a BMI variable, because that's something that we're going to need in the future. So it's really, again, setting up that data to match what it is that you're going to need for your analyses. And yeah, that was just an example of where I imported, and one of my things was string. Time-saving tip. So syntax shows up in the output window. So whenever you run something, the output window, it has that code there. Even if you aren't comfortable with writing some of that syntax or code yourself, it gives it to you after you've kind of done it in the little wizard window. So you can copy and paste that. So save your syntax is my time-saving tip. So you can go to File, New Syntax. It makes it opens up like essentially like a text box. You can copy and paste that over, and that's really helpful because if you can do some of this work with setting up kind of your recoding and your recomputing and everything ahead of time before the study is actually done, it means that when the study is done, you just have to rerun everything you've already written, and it does all that recoding again without you having to go through all the menus and redo everything. So if you know up front, like the data that we're going to get kind of has a certain format, you can do this work ahead of time, save the syntax, and then rerun it again when you have the full data set.
Okay. Okay, so we wanted to go through some checks that you can do. So as I said, part 2 will be you can actually work through some of these checks. So we've said, if you've imported things and it's string, but it's supposed to be numeric, what do you do? What does that look like? So part 2 will be working with the actual paper of going through this process. But the one thing you want to do, the most basic, is a visual check. And this is typically in your data view tab, and you are literally scrolling through your data to check for anything that's weird. So these are just some things that are good questions to ask yourself. So missing data. So as you scroll through, is there any sort of systematic missing data patterns? So For instance, does it look like the control group missed a whole survey that they were supposed to do? So that's more of a systematic missing data pattern, where that has kind of huge implications for any analyses that you're going to run. If it's more random, that's, someone just missed answering a question, or they maybe didn't want to answer a question. It's kind of one or two. It seems random. There's no pattern to it. But the systematic one, you need to figure out why that happened, and then how you're going to work, how you're going to fix the problem. So if a control group missed a survey that they were supposed to do, so you have that survey for the intervention group, but you don't have it for the control group, but you actually need it because it's your primary outcome, then, do you just gasp? So that's not a good thing. So one example here that I had is we wanted to know if people felt really uncomfortable answering the income question in Health Tapestry. So is this a question that lots of people are missing on purpose because they feel uncomfortable answering that? So that's kind of an important piece of information, both for implementation. Maybe we retrain the volunteers to ask it in a different way. Maybe we ask it differently. Maybe we gather that information differently. There wasn't really a pattern there. It was just randomly missed here and there. So that's something you want to look for as you're scrolling through your data. The logic of the data. So sometimes there's a lot of questions within a questionnaire where if you answer in one way, you get some more questions. So let's say, have you fallen in the last year? Yes. Okay, how many times did you fall in the last year? So you want to see in your data, does that pattern make sense? If you set something up in REDCap in a certain way, did that logic and that what's called branching logic, did it make sense? And so that means everything's good, but are people answering no, and then they're getting these other questions that don't really make sense with the survey? So logic of data is another thing. Odd values. So this is where if you are using something that doesn't set parameters around like range of scores, then someone could enter in a weird value that your age is 150 years old. So you can kind of visually pick that up. If everyone looks within a range and then you get this really big number, you're going to say, okay, that's probably a data entry error or something else is going on. But you can visually check for that. And then sample size, group sizes, just kind of the completeness of your data. So if you did import things from REDCap and you only get your intervention group, that's weird. So you should have your control group too. Are there people in there that shouldn't be in there? So let's say you're only interested in two groups, intervention and control, but then later on you want to test feasibility of something else. And these three people in that feasibility are in your big data set, but you actually don't want them in there. You can kind of, you can delete them or you can do it in another way, but it's a really quick and easy way to see, does your data make sense? Does it seem okay? Okay, then there's something called, I call these the run checks. So that is just visually scrolling through your data set. This is where you're going to run things in SPSS to check, again, is your data okay? And this is often used with the analyze descriptive frequencies buttons. And we're going to, next part 2, we're going to have output from these things, and you can kind of sift through it to see, what's problematic. But some of the questions you can ask yourself here is, are the data within the possible range of scores? So if something is supposed to range between 1 and 5, and you've run some things and you have 3 that are 50, that tells you that those people, something weird happened. So that could be a data entry error because they're falling outside the range of possible scores. It could be that you computed something differently for those people. It could mean that in REDCap something's weird. So this just tells you, I need to find those 3 cases and figure out what's going on with their data. Another question you want to ask yourself is, what does the variability look like? Oftentimes in research we want variability or else nothing really statistically changes if everyone's the same. And so some things you could do here is maybe you run an analysis, just simple mean and standard deviation. You look at control and intervention, And is there enough, does that variability make sense between those two groups? It could be sort of gender splits between certain groups that you're looking for things to be equal, men and women. But let's say your control group now all of a sudden has they're all men except one, and then your other group is, it just tells you what you're going to run into when you run analyses, some things that you might need to consider. Okay, this is something that I don't think we do enough of, at least in my experience here, is running your Cronbach's alpha for surveys. So what this is usually we use standardized validated surveys, and most times in the literature it says that the internal consistency of this survey is good. So that usually means the alpha is over 70, 0.7 or higher. And so what that means is that the items in that subscale or that survey, they kind of hang together. So if you're asking questions around quality of life and you ask about mobility and pain and depression and these things that make up quality life, people's values, if they have high quality life, they should kind of hang together. So if someone has high quality life, kind of all those domains should be relatively high. So it's just a way to say these items or individual questions kind of hang together. And what you want is your alpha to be 0.7 or higher. So there's a way to do this in SPSS to check your scale to say, is my survey okay? And Melissa mentioned recoding items. So if you didn't recode your items and you ran this Cronbach's alpha, it will not be good. So then it might say, okay, my Cronbach's alpha is not good for this survey. Typically in the literature, it's a solid survey. It's always good. Why is my study not this good? Like what is it about how I did the survey? Or maybe you missed an item. Maybe the items are coded wrong. You just messed that up. Maybe you forgot to recode certain items, so now it doesn't make sense. So this is one thing that you should do is check the internal consistency of your surveys, especially the validated surveys. And then there's also a question, is it too high? So sometimes, I don't think, again, we don't do this enough, but sometimes the internal consistency of surveys are too high. So you'll have 10 questions, let's say, and you've calculated your Cronbach's alpha, your internal consistency, it's 0.97. That tells me, first of all, that survey should be looked at again. And you could probably get at that concept with 2 of the items, not 10. Now, you're not just going to go through and cross some items out because it's validated in a certain way, but it's something to be aware of, I guess.
Well, it means all those measures are measuring the same thing.
Yeah.
At the same way, the same thing.
You could just ask one question.
They're redundant.
So
yeah.
So to do the Cronbach's alpha for the survey, it's analyze, scale, and then reliability analysis, which are the click points. And again, we'll test your knowledge in part 2 around that.
Sorry, can I ask a question?
Yeah.
So with respect to the importance of recoding the data so as to be able to calculate an accurate Cronbach's alpha, or anything like that.
Yeah.
Can you just give an example of if it wasn't recoded, how that would not be computed correctly? Are you talking about variables instead of numeric values and that sort of thing?
Well, it means if you have a scale where, you know how sometimes they'll be asked in the positive and some will be asked in the negative? So a 10 is good, a 10 is good, but then the next one, a 1 is good. You want to reverse code it, right. So then that way all the 10s are your good. So, yeah. Okay. It depends on how the survey asks the questions.
And if you don't recode it, that means your items are hanging together.
Yeah.
And so it'll be 0.4, the Cronbach's
because some of them will be backwards.
Yeah. And then the other run checks thing. So after you know that the structure of your database is okay and the data looks relatively okay, again, something we probably don't do enough of is checking for assumptions for whatever analyses you're going to do. So there's certain assumptions that any good researcher should check before running a t-test, before running an ANOVA, before running, correlations or any other analyses. So things like skewness, kurtosis, there's a lot of other ones, checking for outliers, those types of things. And so that's another step that we definitely don't have time to go into today, but that's where you start to check for some of these assumptions. And then if things are wonky, so if your data is really skewed, then you have to decide as a research team, what are we going to do? Are we going to transform the data? Are we going to delete all our outliers? Are we going to change their values so that they're still an outlier but not as much of an outlier because they're really pulling your distribution in a certain way? And so this would be the next thing you would do. That, again, we don't have time to do that.
And plots. Plots are good. Next. Right. So these are common oopsies and fixies. So we've kind of touched on some of these, but it's a good little review here. So like one of the oopsies is if your frequencies or other basic descriptives just won't run, like you go through the menu and you try and run it and it says, no, I don't want to. It might be, again, that your variable type is set as a string from when you imported the data and it doesn't know how to handle that. Or it might be that the variable measure was incorrectly set to nominal if it was scale or scale if it was nominal. So again, always going back to that structure of your data. If both the mean and the range are higher, like much higher than you would expect, that usually means that your data has some 9.9s or 9.9s somewhere in there and you haven't shared that info with SPSS. So you could set that in that missing part in the variable view. Your mean seems okay, but your range is not. It's usually a data entry error or an issue with recoding. So age is a really common one. So like our mean was normal for age, and we had just been reporting mean. And then for something else, I had to actually put the range with it, and I noticed that it went up to like 130 something years old. So I said to Rick, I don't think we have, somebody than the oldest person in the world in our study. So we went back and we had to go back to the original survey, and it was just a data entry error. But if I had just been looking at the mean the whole time, I wouldn't have noticed that. So so our mean seemed perfectly normal, but our range obviously flagged the issue. And if you have output that no one else can interpret, it's because you don't have your value labels. And some people, it takes a lot of time to actually fill in that whole structure and put in all the descriptions and everything, but it makes life so much easier later, especially if there's somebody else who needs to look at your output. Or like I got something from someone else and it just had 0 and 1 for sex, and I didn't know which one was male or female, and my supervisor didn't know, and he had to go back to the statistician who had to go back. Like, it actually took a long time to figure out that simple detail. And so having your value labels right in there from the beginning just makes life a lot easier, and you're less likely to make mistakes, because even if you think you remember how you coded everything, you may not have a perfect memory. So it's a good thing to do. So take-home message.
Our take-home message: the data structure has to be set before entering data. You can do simple checks to ensure the integrity of the structure and the data before analysis. So hopefully you learned about that. So next time, we are going to go through the more applied piece to this. So we've kind of told you things, and what we plan to do next time is number 6, apply these methods of checking to data output. So our plan is to print out some data output, and maybe we'll work in groups, and there's going to be so many things wrong with that output, and so you'll practice learning how do you detect those wrong things, and then what probably is the root problem to that. So is it around your data itself, or is it around how you've structured your data? And then what are some possible solutions? And same stat time. Any questions?
Good job, Jen.
It's weird because this is about SPSS, but it probably could be about any software program. So how do you actually use SPSS? Like, you can just YouTube it and like, what are the clicks? But you have to really know about data structure, really to use any software program, I think. So.
Yeah, and the presentation from 2017 goes more into some of the analyses
Yeah.
and the more analysis part, but this is, more about the data itself.
Great, thank you.
That was great.
Yeah, and so we will send out the usual form, but use it as a way to put in some requests for next time if they come to you over the next week, and then send that back, and we'll share that with Melissa and Larkin before the next session. Okay, thanks everybody. Thank you.